So in the last part of the video, we went from mass to moles and moles to mass using our molar mass, which we got from the periodic table, and solve for that. Now we're going to take our two pieces that we've done together. So we've gone from moles to mass and mass to moles, and we're going to add that to the moles to particles that we did before. So we're going to go from mass to particles, or you can go from particles to mass. It's just, again, lining up those labels when you're doing your dimensional analysis. Okay? So your next one, okay, is to convert from mass to particles or particles to mass. You will do two conversions. You can do it separately, but I like to do it as one long conversion. But again, you can do it separately if that makes it easier for you. You can convert from mass to moles and then moles to particles, or vice versa. But you really need to know that you're doing two conversions. So that means you're going to have two conversion factors. You're going to have your 1 mole equals your molar mass, okay, which we did in the last section, and then your 1 mole equals 6.022 times 10 to the 23rd, your Avogadro's number. And so you can see that the 1 mole is a thing that's going to be overlapping. Okay, so let's do an example together. So how many particles are in 150 grams of potassium? So again, this is different than what we did in our previous lesson about moles to particles, because I have to go from grams to moles first before I can go from moles to particles. So first thing first, I got to figure out my molar mass. So potassium is K on the periodic table, and I look at it, and it's 39.09 something. So when I do that one spot after the decimal point, my tenths place, it's going to be 39.1. Because it's just one potassium, it doesn't have a subscript, it's going to just be times 1, which is 39.1 grams per mole. So next, I'm going to draw a railroad track. Mine's going to be a little longer. Again, if you want, you can do two small ones, but I like to just do it all as one long one, but whatever is easiest for you to do your conversion with. So my given is 150 grams K. To get rid of grams, I'm going to put it at the bottom, okay? And I know that there's 39.1 grams per what? Oh, that's right, 1 mole. So that 1 mole is going to go on top, okay? So you can see that this gram and this gram is going to cancel out, okay? And I'm left right now with moles. However, moles is not what my question is asking for, so I have to go a little bit further. So I'm going to try to get rid of mole, and how do I do that? Correct. I'm going to go put it in the bottom corner so that this mole and this mole will cancel out. And what do I know about a mole? Well, I know that based on my conversion factor, that there is 6.022 times 10 to the 23rd, okay, particles. So I'm going to cross out everything that matches, and I should only be left with particles. And when I'm going to multiply 150 times 6.022 times 10 to the 23rd, I'm going to take that number and I'm going to divide it by 39.1. Why? Because I'm going to multiply across and then divide by my bottom numbers. Okay? And my answer will be 2.3 times 10 to the 24th, again, because I'm looking at significant figures. Actually, it should be 2.3 something else, but I actually didn't look at my significant figures in this one. It should be 3, not 2. But again, 2.3 times 10 to the 24th, if you get something close to that, you are on the right track. Okay, so here we went from mass to particles, and we were able to figure that out in a longer conversion. Again, if you need to, you could have split it up and done 2 T-charts. You could have went from grams to moles, and then taking that answer, you could have gone from moles to particles. It is the same process, I'm just doing it in a longer fashion. Okay? Now you can go ahead and work on your assignments for this lesson.